Okay, I don't know how long I'm going to have to get this message across to you, but it's time to enter the matrix. We have gone over systems of equations. There are other ways. Linear algebra, terms I can't talk about yet. But in due time, you'll know the secrets of the matrix. Okay, I finally made it to a secure location so we can speak freely about matrices. Sorry I couldn't speak before. There was a lot of things happening. So we're on our way to a full understanding of the matrix and matrices and linear algebra. I want to share with you some terms, some very basic terms to get us started towards that full understanding. Most of this information can be found either in your book or online, or using your classmates to sort of pull in what you know together, and we'll come up with a general understanding. Although this information can be found in these locations, if you need to get in touch with me, you can always use our secure channels, belmont.edmodo.com. I can be accessed there at any time. I have found a way to encrypt your username and password using some virtually unbreakable algorithms. Therefore, I would implore you that as you are logging in, that you look over your shoulder, make sure no one's trying to steal these. We are going to be on the verge of solving 4 equations with 4 unknowns in under a minute. And this sort of thing can't fall into the wrong hands. So let's go to the smartboard, get some of the basics out of the way, and I can set you on your journey. Next mission. A matrix is a rectangular arrangement of numbers in rows and columns. For instance, this matrix, matrix A, is a 2 by 3 matrix. That's the dimensions of this matrix. So it's rows by columns. Rows are horizontal, columns are vertical. There are 2 rows by 3 columns. The name of the matrix is there. Dimensions are 2 by 3. So it's a 2 by 3 matrix. Each one of the things inside, each one of these is an entry. So this is entry 1, 1, first row, first column. That's the 6, and so on from there. There are certain matrices that have special names. So for instance, a row matrix is a matrix with just 1 row. So it's a 1 by something. In this case, a 1 by 4. There's also a column matrix, which is a matrix with only 1 column. So in this case, it's a 2 by 1 matrix. It's called a column matrix because of the single column. A square matrix, which is one of the types of matrices that we'll be dealing with a lot, is a matrix with the same number of rows and columns. So there's a 3 by 3 matrix. You could have 4 by 4, 5 by 5, and so on from there. And a zero matrix is a matrix whose entries are all 0, just like you see there. To add matrices, first thing that has to happen, they have to have the same dimensions. So in this particular case, we have a 3 by 1, and we're adding that to another 3 by 1, so that should be fine. Fairly simple process. All you do is add the corresponding entries. So in this particular case, we're going to end up with a 3 by 1. We would have 4. We would have 4, -4, 10. That would be the solution matrix for that addition. For subtraction, same idea. Have to have the same dimensions, 2 by 2. We're subtracting a 2 by 2 from that. Subtract the corresponding entries. So the 2 by 2 matrix will be 6, 10, -2, 1 will be the solution matrix for that subtraction problem. In this case, we have 2 by 2 plus a 2 by 1, and I probably don't need to tell you, this is a No way, Jose. Can't add these two because they don't have the same dimensions. When you have a real number that you're multiplying by a matrix, this number is called a scalar. In physics, we talk about a scalar as being something with magnitude but no direction, as opposed to a vector, which has both magnitude and direction. A scalar just has magnitude. So like the number 3 in this particular case, 3 is a scalar. There are some, I'm going to let you think about this one. Is time a scalar or a vector? Physicists can't really, or don't necessarily agree on that. So does time have direction? So is time a scalar, or would it be a vector quantity? All right, so we put together all the stuff that we just talked about. We can solve a matrix problem that looks kind of like a match. You have a scalar outside of two matrices being added together, and we have this solution matrix. So we need to try to solve for x and y. A couple of different ways you could go about this, but one way would be to do the stuff in parentheses first, and you get something that looks like this because you're adding the corresponding entries. So we have 2 times stuff inside of this 2 by 2 matrix. So the next step would be then to distribute the 2 to both of those. So now we have a 2 by 2 matrix equal to a 2 by 2 matrix. Because of that fact, the corresponding entries have to be equal if the matrices are equal. So that means that 6x plus 8 equals 26, and also that 10 minus 2y has to be equal to 8. So you can set those two up in a little 2-step algebraic equation and solve for x and y. And just a little review of, or a summary of some of the properties of matrices. The associative property holds true. So we have that if you add up A and B and then add C, it's the same as taking A, adding that up after you have both B and C. So it's just about the grouping. The commutative property of addition, A plus B equals B plus A. This holds true. Now this is not going to be true for necessarily true for multiplication and division, so keep that in mind. We also have the distributive property of addition. You have some scalar quantity, and you can distribute that to each of the items inside of parentheses under addition or subtraction. Works very nicely in either of those. It's on to the mission.
I'm glad you could make it to my office. I had to take the smartboard mobile. Things are a lot worse than I thought. People are trying to get this information. It's up to you to learn it, protect it, use it. Your mission, whether you choose to accept it or not.